Here's problem 4.10. At the lowest point in a vertical dive, radius of 0.58 kilometers, an airplane has a speed of 300 kilometers per hour, which is not changing. Determine the magnitude of the acceleration of the pilot at this lowest point. Well, if the speed is not changing, there's no tangential acceleration, so it's totally circular or radial centripetal acceleration. So let's imagine this loop. Pilot's going through this loop of some radius r. R is equal to 580 meters, 0.858 kilometers. And the pilot's at the bottom of this loop, traveling at some velocity, and the velocity is equal to 300 kilometers per hour. We need to change that to meters per second. So we know that there's 1,000 meters per kilometer, and there is 1 hour and 3,600 seconds. So knocking out kilometers and knocking out hours, we have that this is equal to 300 times 1,000 over 3,600, or 1 over 3.6. So this is equal to 83.3 meters per second. So that's our velocity for this plane. Our centripetal acceleration is equal to the velocity squared over the radius of the curvature. 83.3 squared over 580 meters will give us the centripetal acceleration, which is 11.97 meters per second squared, or we can round that to 12.0 meters per second squared. That is our centripetal acceleration. What's to note here is that we have gravity acting on this plane, we have air friction, we have the engine of the plane, all contributing and ultimately giving it a net acceleration of 12 meters per second squared upward at this point towards the center of this circle. And that's strictly the acceleration, 12.0 meters per second squared.